We've seen how we can make the for loop into an expression using a yield. We've seen how we can restrict certain values from being produced by putting in if guards. It turns out there's more that we can do with the for loop. One of the other abilities that it has is the ability to add multiple generators. Now by generator, I mean that little thing with the arrow that we read as in. So we started off with a loop that looked something like that. This causes I to be pulled from the sequence 1 to 10, and we've seen that 1 to 10 is a range. Turns out that we are allowed to put in multiple of these. So in addition to having I go from 1 to 10, we can have J go from 1 to 10 as well. Well, that raises the interesting question, what is that going to do? We could do a print line of the two values and see what happens. How many things is this going to print? Is it going to print 1 and 1 and 2 and 2, or is it going to do something different? And it turns out the answer is it does something different. This is like a nested loop. For every value of I, J goes through all of the values that it would have. So when I is 1, J goes from 1 to 10. And then I goes up to 2, and J goes from 1 to 10, etc., etc. If we do this with a yield, so for example, if we make the tuple I comma j, we get back a collection that is just a one-dimensional collection. So it will wind up having 100 elements in it. We could test that by saying res1.length, and sure enough, there's 100 elements. 1, 1, 1, 2, 1, 3, up to 110, 2, 1, 2, 2, 2, 3, etc., all the way through. So we could make kind of a little set of multiplication facts by making a 3 tuple in there, where we have the first value, the second value, and then the product of the two. But unlike a table for multiplication, this is one-dimensional. We'll come back to that later for how we'd make multi-dimensional things using for loops. You're not limited to just 2 of these, 3, 4, 5, however many you feel like putting in there, but do remember that the number of times that this happens grows in a multiplicative way. Since we're doing this, it's worth showing that the inner one can actually depend upon the outer one. So we can make it so J depends upon I. Perhaps instead of having J go from 1 to 10, we'll have it go from I to 10. Now on the outside here, it's the same, goes from 1, 1, 1, 2, 1, 3 up to 110. The next one though, instead of being 2, 1, starts at 2, 2, 2, 3, and then we start at 3, 3, and then 4, 4, and 5, 5, etc. So the sets keep getting smaller and smaller because J is covering less values as I gets larger and larger. So if you want to kind of go across multiple different collections and do possibly comparisons or selecting things that are combinations of those multiple collections, you can do that using multiple generators inside of a for loop. Possibly another thing that we might want to do would be to generate a grid of points. And for this, so I'm going to take X, but I want my grid to kind of go from the space of minus 1.0 to 1.0, and because I'm doing this with doubles, I have to give it a step size, and then Y is going to be pulled from, I'm going to use the same range of values, and by producing a tuple here, what this winds up building for me is I now have a grid of values in X, Y. And so I could use this for various functions where I kind of needed to have a grid of values to compare to.